So this video presentation is going to look at structure stabilizing interactions uh, with regard in particular to protein formation. So what exactly are structure stabilizing interactions? Well, they can be defined as an attractive or repulsive force between molecules. Um, Basically, they're intermolecular forces. So forces exerted by one molecule on another molecule close by. They play an important role in protein folding in the secondary structure of protein formation, and that's what we're going to take a look at. The van der Waals forces is the term given generally to these type of intermolecular forces, uh, also known as London dispersion forces. Individually, they're very weak, much weaker than the force exerted through covalent bonds where electrons are shared. However, if you have enough of these, they're going to add up to give a significant force, which we're going to see again now in the protein formation. So the first type of van der Waals force we're going to take a look at are dipole-dipole interactions. Now these can occur in two forms. They can be permanent dipole-dipole interactions, which occur in bonds between two atoms where one is more highly electronegative than the other, meaning it has a higher tendency to pull the electrons closer, sharing them unevenly and creating a partial positive charge in one section of the molecule and a partial negative charge on the other side. The other type that can occur is instantaneous dipole-dipole interactions, and we're going to take a look at this diagram. So if you have two atoms, one with a valence electron occupying this side of the electron cloud, it's going to create a partial negative charge beside the electron, or on the side of the electron, and a partial positive charge on the opposite side. Same again for the second one on the right here. If the electron is occupying this portion of the cloud on the bottom, you're going to get a partial negative charge on the bottom and a partial positive charge on the top. Now these are going to, obviously opposites attract, so they're going to be attracted to each other. And this is what we call a temporary dipole, as it only happens at one instant in time, because obviously these electrons are going to be moving around and changing position at all times. But if you have lots of these atoms, each one of these weak forces are going to add up to create a strong force overall. And the closer together these atoms are, the stronger the forces are going to be. So just want to take a look at the peptide bond in the primary structure of protein formation, because this is a good example of a structure stabilizing interaction at work. So you're going to get the carboxyl group from the first amino acid is going to bond with the amino group from the second amino acid, and what's going to be formed is, well, H2O, a molecule of H2O, and then you're going to get this polymer bonded by this peptide bond, which is a partial double bond. And that's important because it's this partial double bond is going to give the polymer structural rigidity, which is going to mean it's going to prevent it from twisting, keeping the hydrogen and the oxygen in trans. This is going to be particularly important during the local folding process, which we're going to see next. So if we take a look at how hydrogen bonding plays a role in the folding process, we can see we have three peptide chains stacked one on top of the other here. And due to the fact that the peptide bond is providing some structure here, we're getting our hydrogen kept on the top here. You can see it here better maybe, and the oxygen is going to be on the bottom. So the peptide bond has kept these orientated correctly, so as hydrogen bonding can occur between the peptide chains, which are stacked one on top of the other. So obviously, because oxygen is highly electronegative and hydrogen has a low electronegative value, we're going to get hydrogen bonding occurring between this oxygen and the hydrogen on the peptide chain below, and it's this that's going to cause a helical shape, basically as the peptide chains come together.